This is Kim, and she lives the charmed life of a barista at Newton's Cafe. At 9 a.m., Kim set down a cup of coffee to cool off. At that time, the coffee was 95 degrees Celsius. An hour later, at 10 a.m., Kim came back to the same cup of coffee and measured the temperature, and it was 82 degrees Celsius. We know that during this whole day, Newton's Cafe was kept at a temperature of 20 degrees Celsius.
Right before her break, at noon, a man named Jim came and stole Kim's coffee that she set down. Kim was so sad that Jim stole her coffee. She wanted to know if he even got a good cup of coffee. Kim knows that a good cup of coffee is between 90 and 76 degrees Celsius. So she was sure hoping that Jim's coffee wasn't as good as he was hoping. Here is all of the information we need for this problem. So we know that good coffee is between 90 and 76 degrees Celsius. The temperature of the surroundings, or the coffee shop, was 20 degrees Celsius. At time 0, or when Kim set the coffee down, it was 95 degrees Celsius. 1 hour later at 10, the coffee was at 82 degrees Celsius. And when Jim stole the coffee at noon, that's T3. We're not sure what that is, but we'll find out.
We can use the values that we just put in our table and put them into these equations. Newton's law of cooling equation is the difference in temperature over the difference in time, and that is equal to K, which is the constant rate of cooling, times the temperature at a time minus the surrounding or constant temperature. We can't use that equation to solve for any other numbers or values, so we have to convert it into another equation. That is why we write it as KY and let Y stand for the T minus TS. That way we can put it into the bottom equation, which is Y equals Y value 0 EKT. The first step in converting these equations is we can put in the value 20 for the surrounding temperature because we know that that was the temperature of the cafe all day long. So those are the values that we put in blue. Now we have this equation that we're going to work with throughout the rest of the problem. So to solve for Y is 0, you take the temperature at 0 and subtract the temperature constant, or the temperature of the surrounding.
So once we put those values in, we'll get Y of 0 equals 95 minus 20, which will equal 75. Using that new Y of 0, we can plug that in, equaling T of T minus 20 equals 75 EKT. So we can simplify that equation by adding 20 to both sides, which will give you T of T equals 20 plus 75 EKT. So the next part of the equation that we are trying to find is the value of K. In order to do that, we're going to replace the temperature of time with T1, which will equal 20 plus 75 EKT, which will be time 1. That will equal 82 equals 20 plus 75 EK1 because it was at time 1.
Okay, now we worked a little bit ahead, but don't get confused. All we did was we started to solve for K. So we started by subtracting the 20 over to the side with the 82. That leaves us with 62. Then we divided the 75 over, which is 62 over 75, leaving EK times 1 on the other side. To get rid of an E, you take the natural log of both sides, which leaves you with ln of 62 over 75 equals K times 1, and then we divided the 1 over to the other side. So you ended up with ln of 62 over 75 all over 1 equals K, and when you plug that into your calculator, you get negative 0.19. To help keep things straight, we decided to add the K value to our values table. So now what we're going to do is we're going to plug the K value into our equation and try and solve for the temperature at time 3 by plugging 3 into the T. We'll explain. Okay, here is the equation that we just explained written out. All we did was we plugged the K value that we just solved for, the negative 0.19, in for K. So now we have the equation of the temperature at the time equals 20 plus 75 e to the power of negative 0.19 times T, which would be the hours of time. So looking now at our table of values, we're going to plug 3 in for T and try and solve for the temperature at that time.
So to find the temperature when the coffee was stolen, that will equal 20 plus 75 e to the power of negative 0.19 times 3, which is 3 hours after it was first set down. When you enter all of this information into your calculator, it will equal 62.41 degrees Celsius. We know that Jim's 62.41 degrees Celsius coffee is out of Kim's good coffee range. So we know he got a bad cup of coffee.
After Jim got home and found out he had a yucky cup of coffee, he was so mad he decided to do something even yuckier. So Jim drove all the way back to Newton's Cafe and killed Kim.
Agent M was going home after a long day. He decided he wanted to stop by the coffee shop for some good cup of joe. When he walked in, he discovered Kim's dead body. He recorded the time at 9:00 p.m. He also decided to take her temperature, which was at 30 degrees Celsius. The timeline of Kim's murder is as follows. So her body was found at 9:00 p.m. and her temperature was 30 degrees Celsius. 1 hour later, they recorded her temperature again. At 10, it was 27 degrees Celsius. We know that the temperature of a alive human is 37 degrees Celsius, but we do not know the time that she was killed. So our T of S, or the temperature of surroundings, is 20 degrees Celsius. When she was killed, her body was 37 degrees Celsius, found 30 degrees Celsius, and 1 hour later, it was 27 degrees Celsius. Because this problem uses Newton's law of cooling, we can use the same problems as we did last time. That will equal us with temperature at time minus 20 equals y of 0 EKT. This is exactly the same as the first problem.
Here's where we're going to start seeing the differences between the two problems. We're going to start by finding the y values for each of the following temperatures by plugging in the temperatures and subtracting 20 to find the difference. At T of 0, when Kim was killed, her body was 37 degrees Celsius. You're going to subtract the 20 and you get 17. At the time the cop found the body, her body was 30 degrees Celsius. Subtract the 20 and you get 10. An hour later, her body was 27 degrees Celsius. Subtract the 20 and you get 7. From these values, we know that the value y0 is 17 because the time 0 is 37 minus 20, which is 17. So we can plug that right into our equation for y of 0 value. Okay, now that we have our base equation, we're going to simplify it by moving the 20 to the other side, just like we did in the coffee equation.
We can use this base equation and split it into 2. So we're able to find the time at which Kim was killed. So the first equation we will split it into is the time at which her body was found. We found it to be 10 from our previous chart. So it will be 10 equals 20 plus 17 e to the power of kt. Our second equation, which will be from our previous chart, 1 hour after Kim was killed. So that will equal 7 equals 20 plus 17 e to the power of kt times ek. That e to the power of kt plus 1 is equivalent to ekt times ek. So we can use these two equations, putting number 2 over number 1, which will equal 7 over 10 equal to 20 plus 17 e to the power of kt times e to the power of k over 20 plus 17 e to the power of kt. Because 20 plus 17 e to the power of kt is in both the numerator and denominator, we can cancel it out, leaving us with 7 over 10 equals e to the power of k. To get rid of e, we'll apply the natural log to both sides, leaving us with ln 7 over 10 equals k. Plugging this into your calculator, you'll get negative 0.357 equals k. Looking back at our timeline, now that we found the k value, or the rate of which her body cooled over time, we're going to plug that in to the equation that we found
for y of t, which is when the cop found her body, because we're going to try and solve for t, which will tell us the time difference from when she was killed to when the cop found her body. Okay, now that we have our k value, we can plug that into our t of t equation, which represents the time difference from which she was killed to when Detective M found her body. So we're going to put in 30 for the temperature at the time he found her body, and then we're going to solve. We can do that by subtracting the 20 to the side with the 30. That gives us 10. Then we divide the 17 over, which gives us 10 over 17, leaving e to the power of negative 0.357 t. We're going to take the natural log of both sides and then divide it by negative 0.357. That gives us the natural log of 10 over 17 divided by negative 0.357. And that'll give us t, which is the time difference between when she was killed and when the body was found. So just plug those values into your calculator and you'll get the value for t. All right, so when you plug that all into your calculator, you should have gotten t equals 1.486. So we're gonna time that by 60 minutes, because that's your time value, and that gives you 89 minutes, which is equal to 1 hour and 29 minutes earlier from 9 p.m. So if you do the math, she was killed at approximately 7:31 p.m. Now Detective M can put this into his timeline and say that she was killed about 7:31 p.m. when her body was 37 degrees Celsius. At 9 p.m. he came into the shop and found her, and her body was 30 degrees Celsius. An hour later he measured her temperature again at 10, and it was 27 degrees. He brought this information to the court, and the court ruled that it was enough evidence for Agent M to put Disgusting Jim behind bars for good. Rest in peace, poor Kim.